Tonight, we're lucky enough to have two different presentations, and there's something that I'm interested in. They're all related to robotics. So first, I'm going to introduce Paul Ulland. He's from the Cooley subsection. In fact, he was a co-founder of the Cooley subsection of IEEE. He's a life senior member of IEEE. On top of that, he's also been very involved with FIRST Robotics in the Cooley area. And recently, Cooley subsection, or the Cooley area had their first robotics regional competition there. And Paul was voted. With that kind of introduction, I would like to have you guys put your hands together and welcome Paul Ulland.
Before Paul starts, if you want more pizza, there's plenty of pizza up here, so grab a piece if you hungry.
I don't want to get between you and the pizza. Thank you for giving me this opportunity this evening. It's really a joy on my part. A colleague of mine, Dave Foy, also from the Cooley subsection, were here a number of years ago and talked about robotics and talked about the experiences that we had in La Crosse, trying to explore what kind of interest level there was in our area. And so this presentation really is kind of an update from that presentation. And that particular evening, I had with me a T-shirt, which I still have, that on the front says, "In the beginning, there was nothing." And on the back side, it said, "Because there were no engineers." So this presentation is really going to cover first in its full region of offerings from kindergarten through 12th grade. And where I started was with this advice: "You're crazy," said Becky Hack, who was a coach for 3 first Lego lead teams where we started in La Crescent. "A problem too big," said Woody Flowers. And by all rights, and the first competition that our high school team faced was a competition called Lunacy. How appropriate, we thought. So we're going to look at the IEEE member activities trying to stimulate the K-12 technical interests through robotics. One of the challenges that we found throughout the years of raising lawyers, and they've got most of our companies on the edge of, "Oh, we can't let kids in here for fear of liability." And so it's really hard to have people and young people be exposed to what engineering is all about. And the general public has difficulty understanding what engineering is all about. And so we set off on, well, let's try to make this more relevant. So we started out with an Engineering Week meeting, which we had in the Cooley region for several years, a joint meeting with a number of other professional groups, Society of Mechanical Engineers, WSPE, the Wisconsin Society of Professional Engineers, ASHRAE, the air conditioning, heating, refrigeration system people, as well as IEEE. And we'd come together to celebrate engineering and student accomplishments. We had a scholarship that we offered. We tried to have some fun educational displays and some demonstrations. We tried to explore our common interests and figure out who the stakeholders were and what our action plan might be. We started out by doing a survey of who was interested and how might it apply to our area. So what were our goals? Try to get students to learn and use new technology, find exciting ways to solve new problems, encourage teamwork and can-do attitudes, value the high-quality work, others, and community, and address social issues and social problems. We started out with Lego League, which I'll talk about a little bit more, but some of these are some of the themes that Lego League has had since we began. NanoQuest, the study of nanotechnology, Power Puzzle, how do we generate power, Climate Connections, Smart Moves, how do we move things around transportation-wise, Body Forward, what kinds of things are happening in the biomedical area, Food Factor, Senior Solutions, which I'm getting more interested in, Nature's Fury, which we've seen lots of evidence of in the last year especially. One I really like is World Class, Learning Unleashed. Trash Trek, Animal Allies, and this year's theme is Water Hydrology. So FRC teams are always looking for a underwater competition, but we haven't quite gotten to that yet. So who participates in these programs at first? At this point in time, I think when we first presented this, we had about 190,000 students. Now it's close to 400,000 students, which is, it's growing by leaps and bounds. Who sponsors it? A lot of different organizations sponsor this, schools, industry, clubs like 4-H, Boys and Girls Club, Girl Scouts, and there are lots of volunteers. Out of the 460,000 students, I think there's roughly 200,000 volunteers that help support this program. Oftentimes it's offered as an extended school activity. Youth groups and a number of companies are involved. These are just some of them. I think there's over 300 of the Fortune 500 companies that support FIRST in their programs in one way or another. Thomas Friedman wrote the book, The World is Flat. And his comment was the American education system is not stimulating enough people to go into the sciences, math, and engineering fields. We've done a very poor job of educating our people, and we need to address that situation. Education is not filling a pail, but it's lighting a fire. And so first thrust is not a curriculum, but it's rather an inspiration kind of a program, trying to expose students to something that is really fun and exciting, and oh, by the way, you learn something along the way. The FIRST was founded by inventor Dean Kamen. Dean Kamen is a very prolific inventor. He is the inventor of the Segway. He was the inventor of the first wearable infusion dialysis pump for diabetics. And he was also joined with Dr. Woody Flowers, who, even though he sounds like a cartoon character, was really a professor at MIT in mechanical engineering. And he was charged with trying to find ways to get students involved and interested in the sciences and new creative ways of teaching. And he found that through the use of robotics, students became excited and wanted to learn more. Dean Kamen's vision at FIRST is to try to create a world where science and technology are celebrated. He visited a Nobel Peace Prize winner who had received the Nobel Prize in medicine. And he asked "Can I see your prize?" And he said, "No, I cannot show it to you because it's up in the attic." He says, "Up in the attic? Why is it in the attic?" He said, "Because no one would understand it." And that was a point of inspiration for Dean Kamen. He said, "What are we doing? We have sports heroes, we have entertainment heroes. We don't have any heroes in science and technology. So we are what we celebrate." FIRST offers a range of programs. It started out with the first robotics competition, whose grade level is primarily 9 through 12. Then first Lego League was introduced, grades 4 through 7, 8, and at first it went all the way up to 12, and I think still can. The first Tech Challenge was introduced, which we'll hear more about, and I'm looking forward to that tonight. And just most recently is the first Lego League Junior. 7/10 of communities have all four, is what we learned in St. Louis last spring. We decided as a community of La Crescent, we are going to have all four. So we have started 6 First Lego League Junior teams. And if you can imagine kindergarten through 3rd grade, what a lot of squirrels and what a lot of challenge. And we have started our first Tech Challenge team. So we're interested to see what you have to say. And they're busy, and I recognize some of the pieces. So that's we're looking forward to that. This one's not quite up to date, but what the challenge is for First Lego League Junior is to get kids excited, form a team, work together as a team, put together a display board, put together something out of Legos that moves, and present that to a series of judges. First Lego League itself typically now is ages 9 through 16, grades 4 to 8. And they have 8 weeks on that order, maybe 12 weeks in Minnesota here to do their challenges. And if you look at their challenges, they're all autonomous, if you want to think about it. They have to program their robot to go do a mission all by itself. Unlike the FTC or the FRC programs where they have teleop operation or a tethered operation. I'm not quite sure on, I guess it isn't tethered, is it? But you'll fill us in on that. First Tech Challenge, 12 to 18, grades 7 to 12. It's more accessible, affordable for first. There is kind of a bridge between FLL and FRC. I can talk about that more later if need be. And a lot of good value there, lots of good stuff. First robotics competition, 14 to 18, grades 9 to 12. They're given 6 weeks to go build, design, program, test a robot, put it in a bag. They get the challenge on the first Saturday of January, and Engineers Week, they're done until they go to a competition. So it's a very fast-paced thing. You're crazy, a time too short. 6 weeks you're going to do this? This is crazy. Absolutely crazy. Welcome to lunacy. Building a first community, a lot of people are involved. Businesses, government, education, social investors. It is an investment in our future. It has been demonstrated that the impact of FIRST programs have significant impact. They're twice as likely to go into engineering or science, almost 3 times as likely to specifically go into engineering, almost twice as likely to attend college in the first place. So it's really, really good. Internship, co-op, I've seen that in spades. Employers look at people coming out of FIRST. I asked them, where do they go? They go to the top of the pile. They're one of the first people that are picked. because you've learned some amazing skills that are lifelong skills that people want to have. Lots of sponsors provide a lot of things, parts, scholarships, provide these regionals that we have. There are about 200 scholarship providers, and at this point there's more than $50 million available in scholarship, and they host events. Number of government professional organizations, NASA, IEEE, ASME, UL, SME. Entrance fee, $6,000 for FRC, depending. Ooh, that's expensive. A budget too small. Where do we get those funds? Where do we make that investment? Welcome to First Lunacy. We learned what happens. In the subsection, we did a community ed thing, and we allowed people to sign up in the summer of '06, and out of that came a first Lego League team. Actually, there were 8 of them that started, and through the summers of '07, '08, and to this day, we offer workshops in the summer. They're typically taught by the school people, and maintain teams that are across the board in various schools and various organizations. .4-H was one of those particular organizations that was one of the people that we're going to have join us this evening with Pat Jerk. He's done some really wonderful things with .4-H, and I've got a very soft spot in my heart for .4-H. All of our kids went through that. I went through that. It's really a good organization. But they're also in need of advisors and mentors. Through the first few years, 2005, we had 0. At the end of 2008, we had over 700 students involved in the area. The FRC map kind of looked like this, and the region that we come from, down along across, there wasn't anything. In the beginning, there was nothing. I'm going to fast forward to today, and so today, at the end of this past season, we have a total of 206 students just in FRC alone. And we have several teams. In fact, there are 10 teams listed there. They formed a coalition called the Seven Rivers Robotics Coalition. And they help each other raise funds. They help each other learn what they need to learn. They put together a lot of things. And so now this map, I didn't get this redrawn, but there are now 10 teams right in the La Crosse area. We've added more teams in Wisconsin than, well, we've added about 30% of the teams in Wisconsin at this stage. Minnesota, by the way, has set as a goal to have a team in every school. And they're pretty close to that in terms of FRC. We help sustain all of our 10 local teams. We continued our December training day. We take an entire day and invite teams from the area as well as outside to come and do presentations on various aspects. We offer 4 different tracks that people can follow. We've worked with local sponsors and companies to provide learning opportunities through tours and demonstrations. Been well received. Last spring we were particularly excited because we held our inaugural first Seven Rivers Regional in April at the La Crosse Center. It was the first ever 3-day event, a first robotics competition in that part of the country, that part of the world. We had 51 teams from 6 different states come. It had an impact. Our tourism people gave us of about $2 million to the area with all the people that came. And we are most excited about having people be exposed to what FIRST is all about. It takes about 120 to 150 volunteers to conduct these competitions at FRC level. So we started out with kind of a motley crew. We're called the Sir Lancerbots in La Crescent. And these were our knights at the square tables. And this year we went on to we received our first Woody Flowers Finalist Award, which was pretty awesome. And I don't think we have any round tables yet in our room, but we did expand this year into 2 rooms. And we've combined all of our teams now operating out of those 2 rooms, and they're all helping one another. We were also given the opportunity to go to St. Louis, and it was very, very inspiring and fired this team up. Sponsors, founding sponsors, Society of Mechanical Engineers, our school district, our La Crescent Foundation, Ace Communications Group, IEEE. And I want to say a big, big, big thank you to IEEE for giving us seed money to get this started. We've had really a good return on that investment. I would like to extend also an invitation to you, put on your calendar, save the date. We'll have another regional at the La Crosse Center this coming April in next year, April 4th through the 7th. Last year we coincided with Easter. It was bad timing, but that's how the stars aligned. And it will be at the La Crosse Center. What if we don't have enough students? What if we don't have enough mentors or sponsors or volunteers? These are questions that the team often ask each other. Woody Flower says, a team too big. With it comes a lot of problems. If you want to know more, if you're interested in volunteering, and we'd encourage you to do that at any of these levels, FRC, FTC, First Lego League, FLL, or FLL Junior, visit the website, firstinspires.org. You can go to ways to help, volunteering, and there's all kinds of positions that you can volunteer. You can be a judge, you can be a game announcer, you can be a referee, you can be a control system specialist, you can be a robot inspector, you can be a pit administrator, you can be a crowd controller, you can be a practice pit administrator. There are just many, many areas, and when we say volunteer, we take that very seriously. You're very well fed, but you work very hard for it, and we really love people that volunteer for all 3 days. And you'll be tired, guaranteed. So in Woody Flowers' comment, we challenge teams with real-life situations. We give them a problem too large, a time too short, a budget too small, and a team too big. I've seen teams as small as 1 at FRC level. I've seen teams as large as 80 to 85 kids. Too big. Lots of communication issues. Because that's how life is. So if you participate in any of the FIRST programs, you will learn how to work together as a team. You'll learn how to manage your time. You'll learn how to manage your budget. You'll learn how to communicate. You'll learn how to sell yourself. There are many, many benefits, many, many opportunities. It's an awesome program, and it can accommodate students from very small schools to very large schools. And it's just awesome to watch the interaction that takes place between the students. Welcome to lunacy. John Abley said it's not about people building robots, it's about robots building people. And I would like to leave you with this particular video, if I can make this work. Might need your help here. How do I move into that one? With the mouse, maybe.
Try this. Oops. That's just a picture.
Yeah, that should be a link. Oh, enable the content.
Control click it. Just click it in.
I could begin to the show here, though, don't I? We have audio?
It very well may have hydraulic arms, a drivetrain, and a circuit board. But this isn't a robot. This is a lesson in humility, hard work, and collaboration. This is a CrossFit workout for the muscle upstairs. This is an apple for the next generation of Newtons. It's a lot of things, but this isn't a robot. This is a roadmap that leads straight to engineering. This is a rock to shatter 1,000 glass ceilings, a rope to pull a generation up and out of poverty, a sledgehammer to break down cultural barriers, and a universal language spoken in every nation on earth. And because of that, this is a compass that can help point the way to peace. But please, don't think this is just a robot. This is Glastonbury for technology. This is mission control for the next moonshot. This is the Rosetta Stone to help translate the future. This is the sport that will help us win tomorrow. This is the software to program ourselves to cure cancer, build a clean engine, or step foot on Mars. But this isn't a robot. It's a machine to build the people who will change the world.
Thank you.
Thank you.
Time for questions, or they do that?
You want to do some questions? Is there any questions for Paul? You can come back up.
I figured you wouldn't have any questions.
No? Okay. So, next, I get to present our
It's fine. Ellen.
Just search how to get a black screen.
So this is, now I'd like to present Robot Squad. They're a team in first. They've been a team for about 8 years in various configurations. You're all high school students now? Yep. And they've been fortunate enough to compete all around the country. They've competed at the Worlds in St. Louis. They've been to San Diego. And they've got some pretty impressive work here to show you. So with that, I'll let them introduce each of themselves and then tell you about their team. Thank you.
I'm
I'm Weston.
I'm Michael.
I'm also Nate.
I'll be giving you a little bit of background knowledge on who we are and what we've been doing.
Microphone is not working.
Yeah.
Yes. That's this one.
Try it again.
It's like a switch.
That one worked pretty good.
There's a
It's been intermittent.
microphones are controlled up in the booth.
Been intermittent.
Yeah, be loud. I think for the recording.
Hey, Dave, trying to figure it out.
It's alive.
Okay,
Okay.
there it is.
All right.
Okay, so this is our 9th year as a team, and we've spent it in both FLL and FTC, as well as mentoring junior FLL. So we've participated in 3 of the 4 first programs. We spent 4 years in FLL, where we built Lego robots that went around a little bit of an obstacle course, and then we also had to make a research project on the issue that year's theme was. We did Smart Move, Senior Solutions, Body Forward, and Food Factor. Another part of FLL was the teamwork aspect. So you were judged on how well you worked as a team, which went okay for us the first couple of years, but we got better, and now we're pretty good at it. We're now in our 5th year of FTC, where we build robots like this, and there's less of the research project, but we also have to make an engineering notebook where we document everything that we've done.
So just like about our team and our accomplishments. So we've been a team for 9 years, and of the 4 in FLL, one of those years we made it to San Diego in California, and that was a North American Open tournament for FLL. It was basically, we got 2nd place at our state tournament, and so instead of going to the World Festival, we just went to the North American Open, so it wasn't as exciting. And then the next year, we made it to the World Festival, and that was pretty cool. It's in St. Louis. And then when we switched to FTC, there are 4 levels of competition: the regional, the state, the super regional, and the World Festival. The first year, we made it to super regional, and we were happy, but then we were also kind of disappointed that we didn't make it to the World Festival again, because it was pretty fun and exciting. So then we proceeded to make it to the World Festival the next 3 years. And so it's been pretty exciting, and we've gotten to see a lot of cool people and teams.
How do you guys do fundraising to go to these events?
So a lot of the travel and stuff we just pay for, like our parents just buy. But for the team fundraising, we go around to we look online or whatever for local business and engineering firms in our area, and then we either just cold call them, just go in there with our robot and just talk to them about it, or we email them and maybe people we know donate them. And then we also have fundraisers, like at my church, which is our fiscal partner, which makes us a nonprofit, so people can donate to us and not pay taxes on it. And then, so we hosted a pancake breakfast there, where basically we publicize it, and you can come eat some pancakes and see the robot and donate some money if you want. And so it's just events like that where people can come see the robot and donate money if they want.
Pancakes.
Yeah, question on where was the World Festival held, and roughly how many other countries were there?
It's held in St. Louis, except this year it's changed to Chicago, Detroit and Houston, and then how many countries?
In FTC, there's about 40, 45 countries represented, and about 120 teams there. For FLL, there's about 80 to 100 countries represented, and maybe 150 teams there, something like that. It's really cool. So we got to play beach ball with Lebanon team in FLL and compete against teams from all over.
Going
going back to the fundraisers, one of our biggest fundraisers is selling concessions at an FLL tournament. If you guys are interested in coming and either volunteering or just coming to see some of the FLL stuff happen, that's on December 9th and 10th at Willow Creek, I believe. So that's another really cool event to learn more about robotics, and we'll have our robot for next year there, or for this current year that's going on, and we'll also be selling concessions. You can see all the FLL teams. It's a lot of fun. So now I think we're going to talk about a little bit about what we do in FTC. So just to give you a little information about our robot here. The challenge last year involved shooting wiffle balls into what they call the center vortex, which is kind of like a basketball hoop. Basically, we shoot them in there, and then they fall back down, and you just basically keep shooting them. And there's also a large yoga ball that we have to lift up and place on top of this hoop, which makes it really challenging. So for our robot, what we did is we have a system that is meant to shoot the balls using flywheels, and we pull it in on the other side, and we do all our designing in computer-aided design CAD. I'm sure some of you are familiar with it. And we also have a lift system here to lift up the cat balls, and
this year's challenge is a bit different. It's also very interesting. So we're supposed to pick up these 6-inch cubes and stack them into a 3x4 grid that goes in one of these boxes. And we get extra points if we put them in a pattern. So we're going to try to checkerboard them, for example, to get more points. And we're hoping that our robot can be able to score as many of these as we possibly can during the time constraints. In an FTC match, the first 30 seconds are autonomous like FLL, which means that the robot has to move on its own. And after 30 seconds, there's a break, and then you switch over to remote control. So these glyphs are probably going to be the main thing done in the remote control period of the game. The other aspect is these are called relics, and we're supposed to grab one from the corner of a field and then extend it outside of the field wall and place it upright about 3 feet away from the edge of the field. And then programming challenges that we're having this year, there's going to be a paper with a code on it that's placed outside of the field, so we're going to have to be able to read it using a phone camera that's on the robot. And then using that code, we can get extra points in autonomous by scoring these cubes into the correct locations. Currently, we're just in the initial design phases, so we have some basic CADs and space assignments for these pieces, but nothing concrete yet. We're thinking that we're going to have horizontal flywheels to grab these blocks in, and then a conveyor belt to bring them to the back of the robot. This may be of interest to you specifically because you're connected with the FRC team. One of the big differences between FTC and FRC is that FRC, the robots have a weight constraint, but not necessarily a size constraint. So you tend to see very large robots that are made as light as possible. Whereas in FTC, the robots are constrained so that they have to start in an 18-inch cube, which means robots almost always tend to look like this and fill the space, trying to cram as many things as possible into that area, but not necessarily aiming for light. So you're not going to see people trying to find new materials to make things lighter, but you are going to see lots and lots of space management and trying to make all of our systems still work, even though they're jammed centimeters next to each other. So those are probably the biggest differences, I think.
What do you use for CAD?
This year we're using Autodesk 360 and the other Autodesk CAD programs.
Teams are also allowed to use SolidWorks and HC Creo, so a lot of teams use that as well.
One of our biggest challenges that we've had throughout the years that really got us last year at Worlds, made me sad, was static. So as teams drive around on these 12 by 12 foot playing fields with foam floors, there's a huge amount of static buildup. And so when teams hit things that are metal, sometimes robots will shock out and die mid-match. And this caused us to lose a couple matches at the World Championship last year, which was very disappointing. So this year, we are trying to do as much research as we can to try to prevent static shock, perhaps coating the outside of a robot or adding other components to prevent static.
We're always looking for ways to connect to the engineers in our community to help us with our robot design, and also see if we can get more interest in the FIRST programs and get more volunteers to help at tournaments and to help start teams. So, yeah, we'd love to talk to you guys at some point.
How did you learn your CAD skills?
We actually learned our CAD skills basically by teaching ourselves. Well, at first at school they had a quarter-long course that we took in like 7th grade to learn a little bit of it, and that's kind of how we got started. But after that, we basically taught ourselves. Our mentors had very little knowledge about how to use CAD, so it was kind of a learning experience for everybody, including the mentors. It was.
Our team isn't actually hosted through the school district, so while there are many teams that are hosted through school districts, our team is a little bit separated in that way. So we don't usually learn our skills through the school district. We either learn them through our mentors, our parents, or by teaching it ourselves.
Yeah, and also along with that CAD, we do 3D print a fair amount of parts. On our robot here, some of our main parts that are 3D printed. In our intake system, we've got these pieces that kind of hold them together, these little grips to pull the balls in that are 3D printed, as well as underneath there's a little intake slope, which the balls can roll up as it's moving up, as well as just some other parts that are holding our robot together. And so throughout the season, we document everything in our engineering notebook, so really we strive to be like our own little business almost as we're working on this project. So in there, yeah, we've got documentation of all our meetings, our design strategies, any session that we really do together, as well as like sponsor and business information. So like Nathan was saying, since we aren't school funded, we're always looking for new sponsors, and we love to interact with local businesses and engineering firms. So if you are interested in working with us or talking with us, you can find us on Facebook and just send us a message. And yeah, we would love to interact with you and let you know more about FIRST. Yeah.
What is your home base?
What was that?
What is your home base where you do your work?
Our home base is actually in her garage.
What town?
What town?
That's here in Rochester.
It's a little hard for me to tell what materials are being used in that robot, but where do you fabricate the components? In other words, it looks like there's some sheet metal and gallic parts and such.
So there are like some kits that you can buy, which a lot of the newer teams use. However, recently we've moved away from those, and so we are using like some extruded aluminum and just some sheet metal.
Generally, we can buy some parts in stores. Like there are like beams, for example, that we found that we really like. So we buy those and then we cut them to length with metal saws, or sheet metal that we can cut with a hacksaw or metal saw and a drill press. Sometimes for very precise pieces, we have access now to a CNC, so we actually mill some plates for our robot if they need to be very precise. And if something needs to be a custom shape but doesn't necessarily have to be metal, then we would 3D print it.
How much money do you spend on one of these projects?
Yeah, it varies a lot by your team and what materials you use and how much you spend. Like, you can choose to spend as much as you want. We usually spend around $3,000 a year but we end up usually building around 2 robots a year, and we spend a little bit more because we're trying to compete at a high level. So,
typical team buying stuff out of the kits probably doesn't spend more than like $1,000 probably, which is why it's one of the reasons why FTC is starting to become a little bit more prevalent than FRC, or it's at least growing more quickly. It's just because it's a lot cheaper to implement. You don't have to buy so many giant metal pieces, basically.
there are a lot of extra costs, though, beyond the robot, such as registration fees and like tournament entry fees and stuff like that, and also transportation fees, which most teams do have to fundraise for that as well. Currently, we have access to one in a lab at Mayo, because one of our mentors works at Mayo, and he got us access to it, which was nice.
What programming languages do you use?
Yeah, we use Java right now. The current system uses Java, which actually I should talk a little bit about that. The way the robot is run is we use Android phones, and there's an app set up to connect using Wi-Fi direct between the phones, and we have to download onto the phones code that we write in something called Android Studio, which is a programming language for Java, which has a software development kit meant for the robots to make it a little bit easier.
And you've been doing this for a while, and it sounds like you do multiple robots per year as well. How much are you able to reuse from one generation to the next, in both terms of the actual machines and the codes?
So in previous years for the robot itself, we've been able to reuse quite a bit of it. We usually take apart the previous year's robots to scrounge around for parts for the new year. We haven't taken this one apart yet because we don't have a new robot ready. We like to have one ready to demo. But a lot of the times in the most recent years, we've been building 2 robots so that we have one as a work in progress and then one the programmers can use so that we always have something we can be working on. For the code, we can reuse quite a bit of it.
Yeah, so I think it was 2 years ago it switched from C to Java. So we had to start new from there, but we were able to make function libraries and just change a few variables in certain places like wheel diameter and stuff that allows us to keep using the same code for new robots while just maybe changing around a few things. But each new year has like the different challenge that we have to reprogram like all the new like some new autonomous function that we might need for that year and the new routes that we'll have to be using, and then all the new parts that we'll add on to the robot we'll have to program new things for.
We've been pretty lucky because we keep using the same drive system, so we can reuse most of our drive code.
So one of the cool things about our robot specifically is our drive system. So we're using something called a Mecanum drive, and that's these fancy looking wheels here. And what that does is it allows us to drive forward and backward normally, but we can also spin these wheels 2 in and 2 out, and that will allow our robot to drive sideways on the field while maintaining the same orientation. This helps our drive team out a lot because they can line up to stuff easier if they need to aim towards something, and it just allows for greater maneuverability on the field. I've personally watched them dodge defenders with this, which was pretty fun.
We have 8 members this year. Previously, it's been anywhere from 6 to 10.
Are all your members the same year in high school? Are you all
Not quite. There are 7 of us that are seniors, and then we have 1 freshman on the team.
So what's going to happen next year?
He'll probably end up joining the local FRC team.
How do you divide up the responsibilities for power, mechanical subsystems, et cetera? How do you divide up that?
So because we're a smaller team, we have to do a lot of different roles, but we get to pick our own roles. Like I'm on the business and the programming team. Michael's on every team. So we do a lot of what we want. We just make sure everything gets done somehow.
How many teams in Rochester?
There's 2 FTC teams. There's one other one now.
to see if we can add more or get more people interested. And hopefully, as people age out of FLL, because there's quite a large first LEGO League presence in Rochester, hopefully once they graduate from that, more FTC teams will start forming.
I think this year there's about 170 teams in Minnesota for FTC. There's like 600 some FLL teams and 200 some FRC teams, so it's quite a big first presence in Minnesota. But there's not a ton of teams in the southeast Minnesota area, and we'd really like to expand that. So we're kind of working to try to find ways to get more people to learn about FIRST and be more involved in the programs. It's a really great program.
If any of you have any interest in forming a team, we'd love to talk to you about it or help you out.
How much time do you spend on this?
I mean, depends on who you are, how good your team is, and how much, I don't know. Because for one member that's working on only one subgroup, it's maybe 5 or 6 hours a week. But I'm on all the subgroups. I probably spend more like 10 hours a week, unless it's right before a tournament, and then it's like 25 hours a week or something like that. So especially right before tournaments, it gets rough. But I'm not exactly sure for like a typical like regional level team. I wouldn't know.
It also depends on if the members of your team have other activities going on. Like most of us have other sports in the fall we're doing, so then we have some times where we're really busy with our school stuff and other times where we can focus on robotics.
One of the great things about the program is that you basically can put in as much time as you want, and just the more time you put in, the better you'll do. But if you don't have that much time, you can still do it, and you'll still have a great time, and you'll still learn a ton.
For those of you that are seniors, what are your plans for the next year?
I think all of us are planning on going to college and going into some sort of STEM-based career, major and stuff. We're also hoping, I know at least some of us are hoping to stay involved in the FIRST programs and hopefully mentor some teams at wherever college they're going to.
The U of M actually has a club called Go First for FIRST alumni, where you can still participate by volunteering or mentoring other teams, and they help you connect with teams that need it. So the challenge comes out in April, and we have a September. Sorry, it ends in April with World Festival. But we have our first regional tournament in November, but we can keep working on it. We have far more than 6 weeks.
That's one of the other major differences between FTC and FRC. Even though they're the same age group, FRC, as you know, has a very limited build season, only 6 weeks to work on a robot. And so the best teams tend to be the ones that come up with the best robot the most quickly. In FTC, there's a little bit of a different attitude. You're allowed to continue working on your robot the entire season and even build more than one in the course of a season, which means it's much more about getting feedback from a tournament and then improving your designs, and then slowly and incrementally building your robot over time to become the best it can be by the time your season is over.
I think it's been about 6 weeks since the season started, and we don't have a robot yet.
Is it considered okay that if you go to a tournament and you see some really good ideas from other teams, that you just kind of incorporate those into your next build modification?
That's actually encouraged.
So one of the really cool things that a lot of teams do is they actually share all of their designs with, they put it out on the internet so everybody can see it. We don't do that, but we should do that. So we might put it out once we have a design finalized. But yeah, it's really cool because the community in FTC and FRC is really supportive of other teams, and they want everybody to succeed.
In your competition, you got 4 robots on the field at one time?
Yeah, there's 4 robots on a field, 2 versus 2. Alliance selection, just specifically aimed at you, there's still 3 teams per alliance, but you have to rotate which teams are on the field at any given time. So you can only have 2 on the field at once.
And explaining how the actual tournaments go is usually they have qualification rounds where you're paired, like your partner is going to be a random team and your opponents are going to be random. But once you finish the qualification rounds, the highest ranked teams become captains, and they get to choose who they want to be on their alliance going into the elimination rounds, which makes for a lot of fun because you get to compete with all sorts of teams, and you get to choose who you want to be with if you're one of the captains, and that you end up being with some teams, getting to know some teams pretty well because of that.
So part of that, if you're a captain, is scouting as well. So you have to watch the other teams and see how you think they'd interact with your robot. So even if you don't play with or against one of the other teams, you can still choose them because you have watched how and what they've done.
Yeah, so if we just have a few minutes, we'll just do a quick robot demo, if that's okay.
Sounds good. Thank you.
One thing that they've recently added to the, since they recently allowed Android phones to be used as the control systems, they started using the cameras as vision systems for the robots. We were one of the few teams that actually used it last year. It was quite challenging because it was not very easy to use because it was very new software. But we used that last year to help us align to something called the beacon, which is basically just an electronic thing that had 2 different colors on it, and you had to choose the right color in autonomous mode. So it'll be very well lined up to it in order to hit the right button, since it was just a small, half-inch button. And you also had to be able to determine which color was which. And this year, Michael earlier talked about how there's a picture on the wall of the field, and you have to use that same vision system to determine what code is on it, and that will tell you which column to put it into the box to score extra points.
Well, like we talked about earlier, the main goal of these, the teleop part, was to shoot the balls into a large center structure that was how tall? Yeah, it's. And then, so we spin up the flywheels, and then we just shoot them out. So we had to find a consistent method of doing it. So we had to go through multiple different prototypes. So we started out with a 1 flywheel system, but we found it was inconsistent and kind of hard to get the a good amount of height. So then after testing both of the 2 flywheel and 1 flywheel system, we chose the 2 flywheel system. And then so after we shoot the balls, they get scattered around the field kind of randomly, so we have to go and pick them up.
So the idea is for the duration of the teleop period, which is a minute and a half, people would spend almost all of that minute and a half just collecting and shooting these balls as many times as possible, because every time you scored one, it was 5 points.
Part of autonomous allowed you to get more balls during teleop, so teams could have a big advantage because you started out with 3, but if you did something in autonomous, then you could end up with up to 5 balls, which gave you a huge advantage in teleop.
So the other big part of the challenge last year was there was a large yoga ball that was 21 inches in diameter, which makes it very difficult to pick up because your robot is actually smaller than that. So we have a lift system to do that. We didn't bring the ball, but it has to put it on top of the goal that you're shooting into. And we did a linear slide system to lift up it, and we also have this system to release it, which is something that a lot of teams had trouble was releasing the balls. So we found a kind of unique way to do that. Also, the way that the lift is powered is it actually uses a dog clutch system that connects the intake to the lift system, which was basically entirely 3D printed. So that was one of our kind of design challenges from last year because we didn't have enough motors to power the lift without somehow utilizing the motors from somewhere else.
See, there's a rule stating that you can't have more than 8 motors on your robot at once, which means that in order to lift that lift, we had to find a way to transfer power from some other system, and that's why we implemented a clutch there, which meant that our driver could just click a button and then run the same system we used to intake the balls in order to lift up the cat ball. Six. I think 5 or 6.
It's also unique because all of them are parents of team members.
One of the things our team has learned to do over time is have less parent and mentor involvement and try to do more on our own, because it's really you learn a whole lot more when you're doing things yourself. So we do most of the machining, we drill holes, we cut stuff, we do that ourselves with supervision, and we also do all the designing in CAD since most of our parents can't even use CAD anyways.
A big area of growth for us was going out to sponsors by ourselves now that we have our driver's license and are confident enough to speak to them by ourselves. Most of us are introverts. Yeah, we have a couple friend teams where we actually get together outside of robotics, like we've had a couple game nights with 2 other teams in the state.
Also, just through competition, you tend to get to know the teams that you compete with, especially the really good teams from Minnesota. We have become close to just because we've competed with them through all of our levels of competition for several years. So we meet them, we get to know them better, and then we watch when they or us graduate.
We also form inside jokes like an Orange Alliance, because usually there's a red and blue alliance, but since we all have orange t-shirts, we call it the Orange Alliance.
Another really cool thing is you get, like, when you go to the higher levels of competition, you meet teams from out of the state and out of the country even. Like, we've made some pretty good friends with a team from Indiana, I think, called the Robo Raiders. So you get to meet all sorts of people, and you get to learn a whole lot of things, because these teams come up with ideas that you could never have even thought of, and it really helps you grow and just learn more, like, become a better person, become a better robot builder, and all of that. I don't know. I don't watch TV too much, so. It's kind of fun, but I don't watch it too much because I don't really get it. Like, we don't have cable for that, so.
We also work way too hard on our robots to destroy them.
Yeah. All right. Thank you very much, guys. Give them a big round of applause.